Good morning, students. Today we will be discussing spatial domain enhancements. So basically, there are two types of enhancement we will study. One is smoothing, and second one is the sharpening. So moving to the next slide. So I have already told you that we will first talk about the image enhancements in spatial domain. And basically, enhancement is done using the filters. So we will talk about the spatial filters, which will be used for the enhancement of the images, and we will talk about the order statistics filters, and then we will talk about the image sharpening. For sharpening, there are the different type of filters. We will discuss it in the later part of the video. So first we will talk about the smoothing using order statistics filter, and then we will talk about the image sharpening. So as we have already discussed, that intensity value of any pixel in the image can also uh, modified using the neighboring intensity values. As we have talked that uh, we could do point processing and neighborhood processing. So in neighborhood processing, we will consider uh, the pixels which are in the neighborhood of the picture, which is being transformed. So output intensity value at xy depends not only on the intensity value at xy but also on the specified number of neighboring intensity values around x and y. So we are talking about the neighborhood. So I have already told you that we will take a mask of 3 cross 3 or 5 cross 5 or 9 cross 9. Any type of mask we will take, and we will just move this mask in image from left to right and from up to down on the entire image, and the pixel gray level values will be changed according to the components of the mask. So by convoluting this mask, we will get the desired enhancement results. So it is also written here, spatial masks are also called as windows, filters, kernel, or template. So these masks have various names. We call them windows. We also call them filters, kernel, and templates, and that are used to convolve over the entire image for the local enhancement. Basically, the process of moving the mask from left to right and up to down in this way is called as convolution. And the size of mask determines the number of neighborhood pixels, which influence the output value at xy. Means uh, whatever be the size of the mask, that will affect the neighborhood. Suppose we are having a 3 cross 3 mask, then it will be considering uh, three three right neighbors, three down neighbors. Actually, if we see in this way, if we are having 9 pixels, 3 cross 3 pixel mask, then actually what we are doing, uh, we are covering. If we take this pixel as a central pixel, then the pixel left to it will be considered, the pixel right to it will be considered, the pixel up to it will be considered, this pixel diagonally left, pixel diagonally right, pixel diagonally down left, and pixel diagonally down right will be considered. This will be 3 cross 3 neighborhood. In this image we have shown it. This is the mask, and this is the original image, and this is the 3 cross 3 mask. the 3 cross 3 mask after convolution is placed somewhere here, and as we can see mm, the locations, actually if you see, just enlarging it, you see the coordinates of the pixels are given. This is the central pixel and this is the right pixel. We are just giving them 0 and 1. So we are moving to the y, in y direction, so the value of the y changes. If we go up, then value of x will change and value of y will be added to plus 1. So in this way the coordinates are written. If we consider it as central origin, then the coordinates will be like this: 0 1 minus 1 1 1 1. So in the in XY format, the same similar mask is written uh, downside. Again, so pixels of the image section and mask. So this is actually mask, and this mask is being convolved from left to right and up to. So this will be the formula we'll be using. I will show how this formula will work on the image in the coming slides. So if we consider this as a sub image, and this is the mask components, mask coefficients. So the value of the mask coefficients are W1, W2, W3, W4 up to W9. And what we will actually do, we will place this mask on this sub image, which will be also of 3 cross 3, and individual coefficients will be multiplied and summed together. When we place this mask on this mask overlap the subimage, and the coefficients will be multiplied. So in this formula we can say W1 will be on the Z1 and W3 will be on the Z3, W2 will be on the Z2. So what we will do, we simply place this mask on the subimage and coefficient will be multiplied and added together. So in this way we are basically do convolving. This thing will be done for whole image. We will just move the mask on all the sum images of the image and do the same operation. So basically this is known as the convolution. So there are some problems when we are moving the mask. Suppose sometimes the scenario will be like this: this mask will be at the boundary. Suppose this mask is at the boundary, then what will happen? Some coefficients of the mask will be outside the image. Then what we will do? Then we have to make decisions. And suppose this was the scenario. Suppose the mask is here, then this will be another scenario. Suppose the mask will be here, then some components, some coefficients of the mask will be out of the image. Then we have to take some decisions. What we will do? First problem is to discard the problem pixels. We have to discard some problem pixels because they are lying outside the image. Then what can we do? We can pad the border regions. Means suppose if this is the case, the mask pixels are outside the image. And what we will do? We will consider pixels as, sometimes we consider them as 0, or sometimes we will consider them 1 or some other gray values depending upon the our requirements. So this is basically known as the padding. To move the mask in such a way so that the boundary region also doesn't create any problem is done using the padding. So 0 padding is not good, creates artificial lines or edges on the border. So there are some problems when we do padding. It depends upon the values we are choosing for the padding. So there is a problem written that if you pad the 0 in the borders, then it will create artificial lines or edges on the borders when we are convolving the mask. So there are some problems like this when we are doing convolution. So we normally use gray labels on the border pixel to fill up the expanded region. So they are saying in the third line that we will generally use gray labels, some other values of the gray labels at the border pixels to fill the expanded region. So the problem like creating artificial lines or edges on the borders will be removed. So these are some problems when we will perform the mask operations on the image. Now here they have shown that the expanded area by the red colored gray values. So actual image is this, and for the convolution we have just padded the border with some gray values. This is the original image and this is the expanded area. And the area is being expanded only due to the problem of convolving the mask on the border area. So we will just pad the borders with some gray values. Then there are some special filtering for the smoothing. So what the smoothing mean actually, we can see that this is the given image. This is the given image and the size is 500 cross 500, and this is being smoothed, means we are using smoothing filters and convolving this image using a smoothing factor, and the various results by using different size of the mask are shown in the figure. Suppose if we are using 3 cross 3 filter, box filter, we will talk about the box and weighted filters. So if you are using 3 cross 3 box filter, then the result is like this. We can see that the clarity is more in this particular um, image after the convolution. Now, if we do it with the 5 cross 5 filter, we can see the result. When we done it using 9 cross 9 filter, then the result is like this. When we use 15 cross 15 box filter, then the result is like this. And if we are using 35 cross 35 box filter, the result is like this. We have already talked about it. As we increase the size of the mask or the window which is being convolved, then if the size will be increased, then it will perform the blurring in the image. And the more smaller the filter we will use, this will give more smoothing effects. As we have talked in our lecture, in which I have told that if we just take the size of mask 1 cross 1, then it will just simply convert it to the point operation. And if we take the box size as the size of the image, then it will be converted to the global operation, and any other size will lead to the neighborhood operations. So as we increase the size of the box or filter, definitely the result after the processing will be varying. As we can see in this particular slide, the as we are increasing the size, basically the resulting images are being blurred. So more clear effect we are getting in 3 cross 3 filters. So we will be choosing the size of the box filters or the filters based on our needs. Suppose we want faster execution, then we can use large size filters. But if we are in the need of more clarity, then we will be using smaller filters. So this is all about the filtering, and we will talk about the smoothing and sharpening with the help of the different filters in our